This is another operational amplifier problem, and this is a problem where we will use the concept of voltage divider. So in many operational amplifier problems for gate, you will find that the concept of voltage divider comes in very handy. So here is the problem where we have to assume that the operational amplifier is an ideal one, and our target is to find out the output voltage V0. Note that the power supply voltages are plus and minus 18 volt. So this implies that if the output voltage exceeds plus 18 volt, we should write our answer as plus 18 volt. And if it is smaller than negative 18 volt, let's say if the output turns out to be minus 20 volt, we should mention our output V0 as minus of 18 volt, because these are the saturation limits. Okay, so with the circuit shown here, the first objective is to note that if the voltage at the non-inverting input terminal is plus 5 volt, then the voltage at the inverting input terminal should also be plus 5 volt. And then because this is shorted all the way to this node, therefore voltage at this node is equal to plus 5 volt. Now if we look at our understanding of a voltage divider circuit, so if you have a supply, let's say of Vs volts, and then there are two resistances R1 and R2, and we are interested in finding out the voltage at this node, which is actually the voltage drop across the resistance R2. So this is given by R2 divided by R1 plus R2 multiplied by Vs. And so voltage at this node is equal to V of X. So in a same way, if you look at this part of the circuit, representatively these two are same, and therefore this is a voltage divider circuit. And note that because no current can branch through into the input terminal of the op amp, so these are exactly the same, and therefore here R1 is equal to 1.5 kilo ohms, R2 is equal to 1 kilo ohm, and Vs is the same as V0, and this voltage Vx is the same as 5 volts. So we simply plug in this expression here, and we write this as 1 kilo ohm divided by 1.5 plus 1 kilo ohms, and we multiply it by V0, and this should lead to this midpoint voltage, which is given by 5 volt. And it is easy to show that V0 is equal to 5 multiplied by 2.5, which is equal to 12.5 volts. Now note that the saturation voltages are plus and minus 18 volt, and so 12.5 volt is definitely much smaller as compared to 18 volt, and therefore the op amp is still in its amplifying mode. It has not reached its saturation point, and so the answer to this problem is V0 is equal to 12.5 volts. So the takeaway point here is that you have to observe the voltage dividers in operational amplifier circuits, and then using the concept of virtual short, solving for these sort of questions doesn't take more than maybe 30 seconds.